All right, so thank you very much for joining this particular class on advanced data analysis in R. So my name is Clement. I am currently a final year PhD student studying mathematics at Cardiff University in the UK, and I'm also a Vice Chancellor Scholar of the university. So I'm very happy to share with you my knowledge about how to do advanced data analysis, not in any other programming language, but R. Um, I will explain to you why. All right. So if you remember, I gave some 4 bulletin on the Piazza, where with the 4 bulletin, and please make sure you turn off your videos upon entry, so that we don't interfere. Okay. So basically, the first bulletin was to give a brief introduction into mathematical programming and the advantages of R to other programming languages and also other statistical software. So I'll start with that. So at each stage, I'll just tell what we're about to do, first of all, before we start that particular session. So we have literally 5 bullets, and we have to achieve all within 1 hour. So when I start with the first bulletin, then I talk about it. If there's any brief question, maybe I can take 1 or 2 questions. If there's no question, go to the next, because you can always ask questions on the Piazza. And Piazza is very good for us to be able to interact with ourselves. Sometimes someone else can even answer your question. Yeah, so it's not necessarily questions to be only answered by me. If it's beyond anyone, then I come in. So that is it. So the first thing is the brief introduction to mathematical programming. Now, when you talk about programming, people are usually confused. They assume programming is something very strange. So technically, when you talk about programming language, the language is just a way of talking. Okay, so just like some of us are Ghanaians, some are Indians, some are from Spain and other things. So if a Ghanaian is talking to the other colleague, he or she would definitely use some language. And that language is peculiar to only Ghanaians. If an Indian is talking to a fellow Indian, they'll use a peculiar language. So basically, programming languages have some peculiar languages that you need to know. Without knowing the language, there's no way you can communicate with the software. So basically, you are going to tell the software what you want. So when you talk about programming language, programming as a language, it's nothing strange but just communicating with the software. Okay, and then so keep in mind, programming in the context of, let's say, developing a game is different from programming in the context of statistical or mathematical modeling. So let's not confuse programming in, let's say, a typical computer scientist will be developing, let's say, a game, or might be developing let's say, how do you call it, might be developing let's say, an algorithm. Whatever algorithm they might be developing might get nothing to do with mathematical programming. Okay, so let's not confuse. So someone can be good with developing games or developing softwares, but might not be good with doing any statistical analysis with a language. So keep in mind that there are 2 different things. So all the programming we are going to do, we are not going to develop a program, let's say a program to maybe perform a task outside the context of statistics and mathematics. Okay, we are all going to do things that are in the context of statistics and mathematics. So basically, that's what we are going to do. Now, there are several programming languages. Okay, so we have R, we have Python, we have Java, we have Julia, C++, Fortran, and the rest. But R is noted for statistical analysis specifically. Please try and turn off your video so that we don't interrupt um, your video. Nobel, can you turn off your video? Okay, so let me go ahead. I think he can't hear me. So please turn off your video. Try and turn off your videos. Okay. So with the programming languages, like I was saying, that we have R, we have Python, Java, Julia, and so many. Okay. But why R? So R was purposely developed to do statistical analysis, even though one can also use Python. So Python and R are dominating the field of data science. So if you are into, let's say, data science, or you want to become a professional statistician or a professional mathematician, certainly you will need either R or Python and some other languages, okay? But for R and Python, they are dominating the field of data science if you want to become a data scientist. And what we are going to do today is just a journey to becoming a data scientist. So it's just starting. So we are just starting from scratch, and then we build upon it over time. Okay. So so first of all, for R, with other programming languages, there's a problem called indentation. So when you're writing your codes and you don't align it in a particular way, you might be getting programming errors. And those errors can be frustrating. But with R, you don't have to worry about indentation. So there's nothing like indentation errors. I don't want you to even understand what I mean by the errors. We will see everything shortly. But I just want you to note that R is very user-friendly, and you don't need to indent your code. In some programming languages, you will definitely need to indent your code. Python is one of them. So it can be very frustrating as a beginner if you are programming in Python and you don't know anything about these indentations. And then as far as statistics is concerned, almost every statistical, econometric, or financial models, or let's say disease models, anything you really want to do, you can easily do it in R. Now, why not SPSS, Stata, and eViews and other other statistical softwares? So let's keep in mind that SPSS, eViews, Stata, even MATLAB, arguably, they are not programming languages. However, they were written based on a programming language, but they are not a language on its own. And one thing about, but MATLAB is, let me say, I would definitely say it's a semi-language in a way. But for SPSS, SPSS, eViews, Stata, and the rest, one thing is that there are a lot of statistical analysis or econometric modeling or anything you want to do that might not be possible to do in SPSS. So one of the students for this class purposely joined this class because he's an MPhil student in Ghana, and he was supposed to do a particular test called automated portmanteau test. Now, it's actually a test to test the significance of returns in prices. And would you believe that he was looking for every possible software to do this test, and he couldn't find any but R? So I just want you to note that R has a particular advantage when it comes to doing any form of statistical analysis, because whatever you are interested in, no matter how complicated, people have written maybe existing packages. But we also learn how to develop our own functions. So it's not always that you need a package. So what does the packages do? The packages help you to be able to run some specific functions developed by the owner of the package. Okay, so suppose you want to do this particular test that the guy said he wanted, that automated portmanteau test, and he just couldn't get any software to do, but someone has already written a package to do that in R. So all you need to do is to install the package and load it, and from there you can use all the functions and easily do the task you want to do. So that is one of the advantages of R. And for R, as far as statistics is concerned, whether advanced or not, you can easily do it in R. But it's not everything you can do in R that you can do in Python. Sorry, you can do in SPSS, Stata, eViews, and so on. One person too also called me. She's a PhD student in the UK, and she wanted to do a particular test called nonlinear Granger test. So it's a Granger causality test. I don't want you to understand what I'm talking about. But what happened was she also searched, and it couldn't be done in Stata. Stata could only do a linear Granger causality test. And if she found out that it's only in R that you can do that test. And I'm sure by now she's also part of the class. So this is just to motivate you why you shouldn't be thinking about the other softwares as far as you want to do statistical data analysis. Okay, so if you want to do anything on data science, machine learning, deep learning, no one will use SPSS, no one will use Stata, and the rest. What is dominating is R and Python. But I've explained the advantage. So Python can do almost everything R can do, but not every statistical test. And for Python, it's very good when you're doing numerical studies, especially those in mathematics. And this class is a very diverse class. We have people who are doing their master's, undergrad, even a lot of PhD students are also part of this group. So I'll do my possible best to make sure I'm able to get an intersection of all of you, and then try and explain to make everyone appreciate. So that is, first of all, a brief introduction to mathematical programming and why we are opting for R instead of other softwares. And as I said, it's user-friendly. You don't have to worry about indentations, and there are existing packages for anything you want to do. And apart from that, you can develop your own functions to do any task, even though you can, every programming language can also, you can develop your own functions to do any task in any programming language. But for R, as far as statistics or any form of advanced data analysis, deep learning, machine learning, R is one of the best softwares you can ever use. So R and Python are competing in a way. All right, so now we are just going to start with R. So we are going to open our R Studio. So we can all open our R Studio. And because of time, so what I'll do is that because this video is being recorded, it will be uploaded on YouTube. So don't forget to share and subscribe as well. And you all you get a YouTube video to go over everything we do. So let's open R. So I'm sharing my screen for R. Okay, I hope we can all see this. Can we all see this?
Yes.
Okay.
Yes.
So basically, this is what we call the R Studio. Okay, and then so I'm going to give a brief introduction about R Studio, and then tell you something else you need to know. So basically, there's something you call IDE. IDE is internal development environment. So it's actually an environment where you can run programming languages, okay? And RStudio is one of the IDEs you can use to run R. So the R base I told you to install, you can actually do everything you are going to do today on that. You can actually do all the analysis on the R base. But the reality is that in RStudio, the very moment you start typing, so for instance, I'm going to start typing something. The very moment you start typing, let's say a function, then it starts popping up. So it meant when you're not very familiar with the environment, the RStudio helps you, especially as a beginner, and even experts use RStudio over the R base, okay, because it's user friendly and it makes life very easier. So that's the first of all what we are going to be using. But there's one IDE I'll recommend for you over time when we all get strong. That is called Jupyter Notebook. So Jupyter Notebook is an IDE, and I'm sure by the end of the day, you would have a feel of Jupyter Notebook. Not that we are going to run on it, but you see what I'm talking about. And what it does is that it helps you, first of all, to run more than over 30 programming languages at the same time. So it means you can be doing R, Python, especially if we're into these softwares. You can run R, Python, Julia, and so on it, okay? So, and apart from that, you find out that once you run your codes, your results, your graphs, everything will be just beneath your code, and everything will be stored easily. So you don't have to be copying and pasting your output into, let's say, in Word or something else to save for a later date. But for R, for the R Studio, as you would have to be copying and pasting your output, so your graphs. You could even save it into a repository, which we'll learn how to do that. But technically, you would have to be copying and pasting your results into a different, let's say, document to save. But in RStudio, in Jupyter Notebook, you don't have to do that, okay, because everything is saved directly for you. All right, so keep in mind, R can be used for as a calculator. So you can use R to do anything. So I'm sure you guys don't have this option. Let me close this. Okay, so this is how you guys are seeing your R Studio at the moment. So this part is called, let me delete this. So this part is called the R console. Now with the R console, you can do anything like 2 plus 2. So it means in R, you don't necessarily need a calculator. So you can use R as a calculator, okay? So first of all, you can even multiply, let's say, add 2 vectors. So let's say I have a vector, let's say X, let's say 2, 3. Okay, I can create another one, Y, let's say 4, 5. You understand later on. And then with this, I can easily multiply the 2 by just doing this. You saw I had some error, and it's all because, I use semicolon. Okay, fine. So with this, I just multiplied 2 vectors, okay? So what I'm just trying to make you understand here is that you can use R as a calculator. Apart from the statistical analysis, So you don't need a calculator to do any other thing. You can use R for that. Okay. So now it is never advisable to be typing your codes in the console. Why? Because you can do everything here, okay? But just imagine when I was trying to consider three different things, I had to be using semicolon to be separating that, or else I'll get an error. If I remove this semicolon and I run anything here, I'll get an error, okay? Fine. So, and apart from that, any results you get here, you cannot save. So what we do is that we create a script. We create a script. So this is where we are going to learn how to create a script. So with a script, the beauty is that you just go here, you see below the file, there is a small plus sign at the top left corner. Click on the down arrow. When you click on this, you select the first one, which is R script. So that is when you get a view like this. Okay, so that's the motivation for how to open a script. So let me close it. So to create a script, so like I said, never type your codes in the console. Okay, never type your codes here. So always create a script. So the first one is just click on the down arrow and click this one. So you have your script, and you can always minimize, maximize, minimize this one, increase this, decrease it, but you would always want a large space for your script, okay? And the R Studio has, based on this, it has 4 views, okay? So first of all, we have this view is where your graphs will pop up, and you will see very soon. And this is where any other results, being maybe a statistical test, a statistical model, anything you do will pop up in the console. But with your graphs, they will pop up in this lower right corner, okay, of your R Studio. And then this is where you'll be writing all your codes. This part is where you'll be writing all your codes. I increase the font size. You can increase the font size. So now I can type anything. Let's say advanced data analysis. So now I'm sure most of you can see what I've written. And the reason is that you can go to tools and go to global options. And when you go to global options, there's something called appearance. So you select appearance. So you can actually change even the color of the R page. If your R Studio, if you want it to be black, you can change the color. And then you can change the size. So here we are using a font size of 12. I'm sure your default one is 10. All of you will be having 10. So you can increase it depending on how you can see well. So at the moment I'm using 12. I mean, you can increase it to any font size you want. All right. So now let's case that and do some data analysis. So on the second point, I said also that, so first of all, if you want to do any data analysis, the first thing you need to do is that you have to have your data in maybe Excel, or if it is in CSV file, it's fine. And then it can be in SPSS, it can be in Stata and whatever. But it will always be advisable to have your data in Excel and save it as CSV. How do you save your data as CSV? So if you all downloaded the data in R, if you remember, I told you to download a data called school data. So now I'm going to open that data. Let me open it. So I'm opening that data and I'll show you how to create a data in Excel and save it as a CSV. So we are just starting the data analysis. So the first thing is, if you don't enter your data well, you cannot do any statistical analysis. And we have a particular way every data should be entered. And as you saw in the Excel, in the CSV file that I put on Piazza, that is exactly how you should be entering your data. Okay, always the first row should be the variable names. So I'm opening the data at the moment. Let me stop sharing this. Okay, the data is open now. So let me share the screen. Sure. Okay, so first of all, this is how you should always have your data saved in Excel. Okay, so always the first row should be your variable heading. So Your headings could be anything. Maybe this could be maybe sex. This could be anything. So always, this is how you should what have your data entered in Excel. And when you are done, you go to File. You go to File, then you go to Save As, File, Save As, and Browse. So you have this in the YouTube video, so don't worry. So you can follow it at your own pace. Then here, you click the Save As option. So you see we have Save As type. Then you come and select. So default, you guys were, if you use the standard, how do you call it? The standard Excel, you would be seeing XL, is it .xls extension? But this is the CSV you are looking for. So you realize that there are 3 CSVs already here. So be careful. You are looking for CSV comma delimited. So what I'm saying is that always save your data in an Excel document and then save it as the extension, save it as CSV instead of the normal Excel. Okay. And how to save it as CSV? I said you go to File, Save As, then you go to Browse, then you change the Save As type to CSV, comma delimited. There's CSV Macintosh, there's CSV MS DOS. DOS. That's not what you're looking for. Comma delimited is what you're looking for. So basically, that's in that case, then we say your Excel document or data has been saved as a CSV. So I'm sure by now we all know how to save a data as a CSV file. Okay, it's very handy importing your data as a CSV. Why? If your data is already in SPSS, okay, or is in Stata, or is in eViews, you can actually import them directly into R. Even in SAS, you can import them directly into R, but with that, it will require a package. You can import a data which is already in Excel without the CSV extension. You can import it directly, but you need a package for that. But with the CSV, you don't need a package, and it's very and it's just the same Excel. You are just changing the extension to CSV. Okay, so don't forget that. So now let me stop sharing and open RStudio. Okay, so now let's start to import the data into R. So RStudio. Okay. All right. So so first of all, let's see how we create a script. So we are all going to create a script and save our script and see how we will import our script back. So keep in mind, we use the, is it hashtag? The hashtag sign is used to make comment. So suppose I was writing advanced data analysis and I forgot to bring this. Advanced, and I forgot to bring this. And this is what you'll be using to run. So if you remember, I can type 2 + 2 here, okay? And when it's blinking there, I can just click on the run here and you get your results in the console. So keep in mind, anything in the studio, you can either highlight and run and you get your results in the console, okay? But now let me run what we have here. I can either highlight or not. If I run, I'll get an error, all right? Because this is not a code. It's something different that the programming language doesn't know. So what you do is that you bring the hashtag to represent this is a comment you are making. So always keep in mind to have comments, okay? Try and comment your codes so that in future, if you should pick what you are doing, or you should import your script, you'll be able to know. Maybe here you were trying to create a function to do this. So you should be able to write, okay, creating a function to perform this particular task. So you will see what I'm talking about. So suppose I want to save this script. I've not written anything much here, okay? How would we save it? So first of all, you do the normal save. You go to File, then Save As. And if you remember, I told you to create a folder called data analysis results _R. So let's save it as, let's say, first R script. I'm adding, let's say, 1 to it because I already have saved one as R script. So I click save. So at this point, I have been able to save this R script. So now anything I do, so maybe I can try to simulate a data, or let's say let's say I consider this vector. Let me create something. So let's say you understand everything soon. I'm just doing something small. All right. So suppose this one I'm simulating from a standard normal with mean zero and variance one. Okay. I don't expect you to know what I'm talking about. But with this, so suppose I run. Um, suppose I run this. Okay. I can call what is inside and run that, and we get your results. Keep in mind, this X here, I have used it as something called an object. Always don't write your functions without saving it in an object, or else you will not be able to call it back. So now, since I've been able to save this one in this particular, and you can use any name. I can use Y, I can even use Clement. You can use any name for your object. Okay, so always it's advisable to save your course as in an object. Okay, so with this you can always save it just using Control S, and it will save automatically. Now, I've already written a lot of codes, which we are going to go through each line by line. So now I already have saved it in the file. So I'm going to import it and see how, if you have already saved a script, how will you call it back? So first of all, you go to File, then you go to Open File, okay? And then I want to open the first R script. What I was just doing is the R script with the one. I'm opening this, okay? So with that, all the codes I wrote, which we are going to go through each of them, is very easy, so don't be scared. All the R codes are already saved, okay? It's already saved for us. So basically, that's basically how you would be writing your script, and then you save your script into a particular file, okay, or folder. Now the folder we have, the essence is that now we are going to learn how to import the data that we did. So this is the first thing. So like I said, you can import a CSV file, a Stata file, SPSS, and so on, okay? So now the first thing we are going to do is how we would import our data. There are several ways to import the data that is in our folder. We already have our data saved in a folder. So how would we import it? So you can give any name you want to it. So I will call it data underscore school. So maybe someone is calling it data. And in R, you can either use equal to or use the sign. So keep in mind, the equal to here and this sign represent assigning. Okay, so it means that I'm going to import the data, but what I'm saying is that after importing the data, I should save it as data. Or maybe let me bring underscore school. So what I'm saying is that I'm going to import the data into R, the data that we've already saved, okay, which is in our folder called data analysis. I'm going to import it. I'm saying that it should after coming into R, it should be saved as data school. So there are two ways. One could have just written read.csv. So this is where I said it's a language. So you have to be familiar with the languages, but you don't have to memorize and call. So read.csv, I can use write file.choose. And you realize that as I start typing, it pops up. And that's the beauty for the RStudio. You cannot get it in any of the other IDs. File.choose, then I'll say header equals true. This is a long process, and I wouldn't recommend anyone to go by this. But when you run this option, it will open up. Let's do it. So it will open up, something will pop up. I don't know whether you can see the pop-up screen. So when you run this one, something will pop up like a pop-up screen where you just go and manually select the data. Just go into your folder and click on the data, and it will be imported. But we don't want to do that. So what we first of all are going to do is that we are going to set something called a working directory. So when you set a working directory, what it means is that you can actually import your data directly into the software, okay, or directly into R. And how would you set working directory? So first of all, you use this function. So we are setting a working directory. So don't worry, after everything, I'll write the codes very well, and then you have it also in YouTube as well. So we are just going through how to first of all set a working directory. So you use set wd, then you open bracket. So keep in mind, every function in R, after writing the function, we open this round brackets, okay? And whatever you put in are what we call arguments, okay? So always, that's how every function will look like. So you find out that anytime I'm writing any function, so for instance, name of data, I open a bracket. So always, when you write a function, you open a bracket and the input will be in the bracket, okay? So how would you set your working directory? So now let me go back to my desktop. So let me share my screen for the desktop. Okay. All right. So now I'll go to my desktop, okay? And I'll go and select the folder called data analysis. Now, when you go, so this is actually the folder you save in your, how do you call it? You saved on your desktop. Then you click this side. You see, after clicking, you get this particular link, okay? So this is literally what we call the directory. So copy this directory and go and paste it in R. So I hope you all saw how I did. So you just go to your data, open the folder, as in go to your folder, open the folder and click this side, the upper part, and just copy this link. Then um, let me stop sharing. Okay, so now let me open R now. Yeah, at the beginning it will be a little bit rough, but we would be fine. It's just we are just starting. Okay, so then you open you open these two how do you call this? Um, is it apostrophe or whatever? This one. Anyway, so then you paste your
It's called parentheses.
parenthesis. Perfect. Or parenthesis, someone can use it as brackets anyway, but not necessarily parenthesis, but I mean, whatever you know, parentheses can be a bracket anyway. Fine. So you create that, so and you copy and paste. But after pasting, make sure you change this slanting to face this side. Have you seen what I'm doing? I'm just changing it. Now it's facing towards the right. I want it to face towards the left. Sorry, it's facing towards the left. I want it to face towards the right. And once you have this, you just run. How do you run? Now you see it's blinking on this line. I just click on run, or I can just highlight whatever I want to run and click run. At this point, I've been able to set a working directory. What's the essence of setting a working directory? It means that you can be able to import your data directly into R. You can be able to save all your results also directly into the repository. You can actually save your plot and everything directly into it. But we will not do that for today. But we are going to do some basic analysis as I've already explained. So the first thing is set a working directory. Or else, if you use the other function that I was writing, the read.csv in brackets file.choose, it's going to open another window where you have to manually go and locate where the folder is. And suppose you have a clumsy and a lot of folders on your desktop, just like mine, you might struggle a little bit locating it, okay? But when you set a working directory, you are good to go. So now we are going to, yeah, so now I've set the working directory. And after setting the working directory, remember the data was saved as school underscore data, okay? Then you just add the .csv to it. So once I run this, now I have the data. How do you see you have the data? First of all, you can just run the object. So this is the object that I've saved the data into it. The actual CSV file could have any name, but whatever object name is dependent on you. So I'm choosing to call it data underscore school. You can call it any name you want. And now to see the data, you can just type head in bracket around it. So like I said, any function you write, then the bracket comes. Okay, then you run this. Running means you can just highlight and run. And you can see when you look at the console, you can see I have imported the data. Okay, because you cannot see it clearly, maybe I will use another option. So there are so many things, so many ways. I can also use a square bracket this way and just look at, let's say the first, I want to look at the first, let's say 4 rows. Okay, so I can just run this So this gives us the first 4 rows. Okay, so this means we have imported the data. So this is how easy you can actually import any data, I mean, a CSV file into R. So the first thing is set your working directory. If you don't know anything, set your working directory. That's the first thing. How do you set the working directory? Go into your folder. You created a file or a folder on your desktop. Go to your desktop, open the folder, and go and copy the link. Okay, so that repository, I mean the repository link. Copy it and paste and write set wd and bring those quotation sign. Yeah, that's the word, quotation sign. And then paste. When you paste, don't forget that it would if you paste, you would have it, you have these ones going towards the right, towards the left. You have to change all those and slanting lines towards the right. Once you have that, you just run and you've actually set your working directory. And then the data name was called school underscore data. Suppose next time you save a data called, let's say, blood data. So you can just put that name exactly how you saved it and bring .csv and just run, and you've imported your data. That's how easy to import CSV file into R. All right. Now, if you want to know the variables, the variable names, you just type names in brackets, the name of your data. So I'm calling the data as data underscore school. So once I run this, you will see all the variable names. So suppose you wanted to know the names of the variables of the data. So that is, the first one is name of school, number of students, number of teachers, and so on. All right. So now the next thing is, so now we've learned how to import data directly from your repository. So this is what we mean by working directory. So we've been able to import our data. We've set a working directory. We've been able to import the data without necessarily having to open for something to pop up before we select. Okay. So then now the next thing is, we all know. So for the data, let me run it again. So first of all, the first column is name of school. Okay, and you realize that, let me bring this up a bit. If we're doing it in Jupyter Notebook, you realize that you see everything clearly. But in the R Studio, most of the things would, because it's like one page and everything is happening there. So here is where you'll be seeing your results, and here is where you'll be seeing your plots. Okay. So now we are going to assign some. So for instance, we know the names of the school is fine. Number of students is fine. Number of teachers is fine. Number of NAPCO NSP is fine. Height is fine. Weight is fine. Now, if you check the task, we said the first thing is we are going to create BNI based on height and weight. Okay, so I'm going to tell the formula, then we use the formula to create. So it's more like, suppose you have height and weight, and in your data, you need to create an additional variable called BNI. Now with the BNI you need to create, if you were using Excel, you can see how stressful it will be. You first of all would have to um, 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 multiply the rows, I mean, those 2 rows, and I don't know how stressful you go through, but in R, you can easily do it with just a line of code, okay? So, so that's the first thing we are going to do. So how to add additional variables based on what we already have. So if you have height and weight and you want to create an additional variable called BNI, and after getting the BNI, we'll learn how to categorize such a continuous variable into a categorical variable. So suppose the BNI, you have it, but you want to know the BNI status so that you'll be able to say whether someone is overweight, underweight, normal weight, or obese. How would you be able to do that? So that's the first thing we are going to do. But before then, we have a variable called sex of school, and it has been coded as 312. And then we have region of school. How would you know the level? So as it stands, in R, since only the name of school is written as OWAS, ASAS, OWAS, and so on. Those were the only thing written as a string. So R will automatically consider only that as a string, but it will consider all the others as numbers. So the sex of school, even though I know it's about male school, female school, and mixed school, R will not be able to tell whether 3 is a male school, and one is female school or not, unless you tell it. Okay. So what we are going to do is that first of all, we are going to assign the names to each of these categorical variables. So basically, sets of school and region of school are supposed to be categorical. However, now we only have the numbers or the codes, the dummy codes you have written as 1, 2, 3. Now we want to tell what each stands for. So now the next thing we are going to do is with the school, with a set of, let me minimize this one. Okay. So now we are going to assign the names for sets of school. So now you type data, and you realize that once I start typing, I want to call the object name data underscore school. Once I start typing, it pops up, and that's the beauty. Then use this $sign. So this $sign helps you to extract all the variables. So these are the variables. So I'm interested in sex of school, okay? And then I told you can either use this sign less than with the minus, or you can use equal to. But just that most of the R programmers really prefer this one. But keep in mind, equal to here is different from double equal to. Double equal to is what really means equality in R. But the single equal to is just to assign something to an object, okay? So I will prefer to work with the less than and the equal to and the negative sign, okay? So now we use this function factor. So what we are doing is that we are giving names to the categories of the sex of school. So factor, then you copy this one and paste. So basically, this is trying to say that we want to give names to sex of school. And what are the levels? So suppose you don't even know the levels. Suppose the data is very long and you don't know the levels. Or when I say the levels, I mean the categories. You can write levels, then you write as.factor. The reason why you are writing as.factor is that originally you imported it as 1, 2, 3. So R doesn't know that it's a factor or it's a category. Okay, it only sees it as something numeric. So when you write it as as.factor and you paste it and you run, now it will tell the unique categories. So we have 1, 2, and 3. So keep in mind, this is what you would be using to know the exact categories of the variables. So suppose I want to know the exact categories of, let's say, the first variable, which was names of school. I just have to select, write the data name, then the $sign, then I select the name of school and I run. So once I run this, I will have all the names of the schools at the console. Okay, so fine. So now let's go back to assigning our codes. So we know that the levels for the sets of school is 1, 2, and 3. So then you write levels, then it pops up equals. Then you always use a C. This C is called concatenate. It's called concatenate sign. You cannot write any form of vector without the C. So the levels are 1, then I bring comma 2, comma 3. So if you remember, when I was trying to create a certain vector, let's say I bring 1, 2, 3, for instance. If you don't do this, you get an error. Suppose I take away this C and I run, I'll get an error. It says unexpected. But the very moment I bring the small letter C, not big cap, then you don't get an error, because that's exactly how we used to combine. So the concatenate sign is just to combine those values there as a vector. Okay, so these are the levels. So the levels are just the categories 1, 2, and 3. Okay, now then you give the labels. So these are something new to most of you. So all you are doing now is just to learn how to assign names to some categories. So first of all, the labels. So one is male school. So I put male. If we're doing it in Excel, you can imagine. And then female, especially if your data was very long. And then the last one is mixed school, mixed. So once I do this, remember, originally, if I should run this one for the sets of school, you will see 3, 1, 2. Okay, now I'm running this. So to run this, I just highlight the whole of this particular code which I'm interested to run, and I run this one. So now let's call back. Let's call back. So I just selected the data underscore school, and I just run. So you find out that now I've been able to assign the categories. So sets of school now you can see mixed males and so on. Okay, so it means that you can actually put dummy codes in your Excel document and easily use this simple line of code to assign the names of the categories. That's as simple as that. And the regions, now let's do for the regions. Now to do for the regions too, it will be advisable for us to know the categories of regions. So I just type regions, I bring the dollar sign, then I select regions, region of school. How many levels do we have there? And don't forget, I brought as.factor because the originally regions was also entered as 1, 2, and 3. Okay, so R will not be able to know it's a categorical variable unless you put as.factor around it. So then you run this. So it means this one too has 3 categories. And what are the categories? I think I labeled the first region as Ashanti, the second region as, let me just copy these categories and paste it here. So let me delete this part and paste it here. Okay, so now we are going to create assign names to the variable, the variable called regions. Okay, so the first thing is you delete this, and keep in mind, if you saw what I did, I just copied and pasted something I've already done before. The reason is that it's good to copy and paste, okay, because here I'm just editing this one. I'm just editing this one and I'm selecting regions, and then I'll just copy this one and replace it by this. The levels were also 1, 2, and 3. The only thing I need to change now is we said 1 means Ashanti. So I just put Ashanti here. It looks like a 1 hour is really small anyway. Then Central. And then the next one was Greater Accra. So I'm just using G Accra. Okay, so upon doing this and just highlighting this particular one, okay, and running, we've now been able to also assign. So now if I should, I want to select the last 2 variables. So how many variables did we have? So if I check names of data of data underscore school, we have 1, 2, 3, 4, 5, 6, 7, 8. So sex of school and regions are the 8th, the 7th and 8th. So how I just want to select that for you to know that now our categories are working. So I just bring a comma. So keep in mind, the square bracket is used for indexing, whereas the round bracket is actually used when you are dealing with a function. Okay, or you get it. So keep in mind. So to index or to extract a particular component of your data, you use the square bracket. And then the first index. So if I should put 1 here means that the first row. So suppose I want to see the first row of the data, I can just run this. And this will give me the first row of the data is ASAS, no, and then you see the number of students. So this is just to extract the first. Suppose I want to extract the 10th row. I can just use this to extract the 10th row. Okay, fine. Now I'm interested in, and so the first part is for rows and this part is for columns. So I'm interested in the 7th and 8th. So if I'm interested in the 7th column, I can just put 7 here and just run this. So this one will give me the seventh column, okay, the variables there. So you can now see we are seeing mixed male, female, and so on. So now we're able to assign the names to these categories. But I'm interested in, let's say, extracting both the 7th and 8th. So I can just now bring the concatenate sign. So keep in mind, anytime you want to extract more than one thing, you bring the C in brackets, you put your 7, 8. So this one, if I should run this, now I've been able to extract only the 7th and the 8th. And you can now see the names, you can now see the categories or the names assigned. All right, so we are good to go. Now, suppose we want to do some basic descriptive. So first of all, let's say I want to know let's say the proportion or how many students, how many schools were male schools, how many schools were female schools, and also let's say mixed schools. You use this function called table. So at this stage, we are just trying to get familiar with the commands. Okay, very soon you'll be playing with it, and so this is just the beginning. So if I type tables and I put the variable name, so the variable, you just type the name of the data, okay, and then you bring a dollar sign, and then no, we are not interested in the name of schools. I wanted to know the number of students and the number of schools that are males, females, and so on. So now I've selected this one, and you just run. So this will tell you that 8 of the schools were male schools, 10 of the schools were female schools, and only one was mixed. And you see how easy we can, extract anything we want, and also look for anything we want to do. Okay, if we're doing it in Excel, just imagine if you wanted to know how many were males and females, unless you probably go to filter and so on and so forth. Now, suppose I want to know, I want to get this in proportion. I can now divide this one by the total. So how would I know the total? So I can just put either sum of this. So the sum means that sorry, did I say sum? I want to know the, let me come down here. Yeah, so I want to know the total. Where are we? Okay, so I want to know the total. So I can either use divided by the length of the data. So what's the length of the data? The data, to know the length of the length of the data. So you can use dimension, and you copy the data name, you put it there, and you run. This will help you to know that we have a data which has 19 rows and only 8 columns, 19 rows and 8 columns. And now you've been able to, so that's how you'll be able to know the number of, how do you call it, rows in your data. So now we've been able to know the number of males, females, and how many mixed schools we have. Okay, so now suppose you want to convert this as a proportion. All you need to do is to divide by the total of this one. Okay, so you can either consider divided by length. I copy the same thing and put it here. Or you can use the dimension. So there are so many ways. I can use the dimension of the data. And when I ran the dimension, you saw that we had, the first one is the rows. So I can, and we can use the square brackets to extract. So I'm extracting just the rows. If I wanted to extract just the column, I'll put 2 here. Because don't forget dimension, if I run dimension of the data, it returns 2 things. The first one is the rows, and the second one is the column. But I'm extracting the rows, okay? And because there are 19 schools, okay? And if you are saying that 8 of them are males, 10 of them are female schools, and 1 of them is a mixed school, all I need to do is to divide by 19. And to divide by 19, since this dimension returns a vector, which has the first number to be 19 and the second number to be 8. I'm interested in the first number, so I will use the square bracket. I told you the square bracket is used to extract, okay? Or it's used for indexing. So I can use it to extract anything. So I put the square bracket here and I run this. So at the moment, it's telling me that 42.1% are males, male schools, 52.6 are female, and 5.2 are mixed. All right. So this is just for us to be familiar with how to summarize categorical variables. All right. So the next thing is now, if you want to find means, and then standard deviations and the rest, okay? So in R already has a summary function called summary, and you can put the data there and you can run. Now what the summary function does is, it first of all tells you for each variable, if it's categorical, then it will give how many groups or how many elements are in that category. So if we look at, let's say, sets of school, it is telling me that we have 8 male schools, 10 female schools, and 1 mix. Regions is telling me we have 9 of them are Ashanti region schools, 4 are Central region schools, and 6 are Greater Accra. So it means that the very moment you type summary in brackets, data underscore school, or the name of your data, it will summarize your data. But keep in mind, this might not be the information you need. I might not be interested in the minimum. So for those that are numeric, it returns the minimum, the first quantile, the first quartile, the median, the mean, the third quartile, the maximum. This might not be the information you are interested in. So you can actually tell how to do what you are interested in. All right. So now we've learned how to create the factors or assign names to the to your categorical variables. Now the next thing is we are going to create our own function. And what this function is going to do is that it's going to first of all pick the entire data set and ask whether each variable is categorical or numeric. And if it is numeric or quantitative, it should compute the median, the mean, the median, standard error, standard deviation, and skewness and kurtosis. But if it is categorical, it should compute, how do you call it? The percentages of the categories. So now let's learn how to create a function. So now we know how to import the data. We know how to assign categories to categorical or names to categorical variables in your data. Now the next thing is how to create our own function to do something more. And the function we are creating has never been created in R. So we are going to learn how to create it. So how do we create a function? So always we start with an object name. So let's say I want to call our function summary underscore stats. So I'm calling it summary statistics. Okay. So I can either use the less than with this, or I can use equality to assign. I think I told you that you can either use this or equality. Okay. Just that people prefer this because it looks scary to people who don't use R. So it's just a way of, it's just a flexing thing, but technically you can either use both. Okay. Then you write function. So all the inbuilt functions you are going to be using. So if I want to calculate the mean, for instance, I can just type mean in bracket. Let's say I want to calculate the mean for the number of schools, the number of students. So when I call the data name, okay, I bring my $sign. I select the number of students. Okay, so when I run this tells me the average number of students is 297. Okay, so you realize that we open the round brackets, and then we put in what we are interested in. Okay, so always when you are creating a function, the arguments are put inside this round bracket. All right. So the first thing is this is how we create a function. So and the mean, we cannot even create our own function to calculate just the mean. So before we do the complicated thing, so we already know the mean for this. So suppose we want to create our own function to calculate just the mean. So let's say maybe this is just for the mean. So then we are saying that it will pick anything. So you can put any argument here. I can put y, I can put data, I can put variable. So let me say I'm using variable. Then you open a curly bracket. So this is always the building block of creating a function. So first of all, you write the name, how you want to name the function. Those who created this function call mean. This is what we call an inbuilt function. So R already has this inbuilt function. If I wanted to calculate standard deviation, I can just copy this and paste and change the mean to SD. SD means standard deviation, and you run and you get the standard deviation in terms of the number of students. Okay, so and this is an inbuilt function they have created, and they chose to label it SD. We are labeling ours as summary underscore mean. Okay, so the first thing is you should know the formula. You want to compute the mean. So we are saying that the mean value. So here I chose to use what we call mean value because I'm also using this as an object. So I can use this or equality. Okay, let me use equality here. So the mean value is going to be, we know how to calculate the mean, right? Is the summing all the observation and dividing by the number of observation, summing all the observation and dividing by the total number of observation, okay? So I can write sum in bracket. And then I'm saying that anything I put inside a function, which is the variable, I'm considering the sum of everything, and I'm dividing by what? How many observations? So how many observations will be dependent on the length. So you can use this function called length. Let me take this up. Length in bracket the variable. So so I've just created a function. Oh, it's already 6. All right. So let me add a little bit of time. So I've already created a function, and now what this function is doing is that it's taking any variable. It's taking any variable. It looks like the time is really small for 1 hour. Anyway, so it's taking a variable and it's first of all considering the sum divided by the total number of observation. So you know this is how we naturally calculate the mean, summing. And when you do this, the next thing is to return. So you put return in brackets, return. Now we are returning the mean value. So keep in mind, without returning, you cannot get your outcome. Okay. So now I'll run this function. So now I've run this function. So now if I want to use this function to calculate the mean, I just open a bracket and put the variable I was interested in inside. So now I'm running this variable. We are getting some background. I'm running this variable. So when I run this variable, can you see that it's equal to the inbuilt function? The inbuilt function is mean. Now we have called our summary underscore mean. So that is the beauty about R. You can create your function for anything, okay? Especially when there are no inbuilt function for that. All right. So now we've learned how to create our own function to even calculate the mean. If you wanted to calculate the standard deviation, you could also do that. Okay, fine. So now what we want to do per what I described was to create an inbuilt function that will first of all identify the type of variable. And if it's numerical, it should compute the mean, standard deviation, and other things. Okay. So that's the function we want to create. So after creating this function, maybe we can call it a day for now. And then next week we continue where we left off, because it looks like the 1 hour technically is not enough for us, because this is the beginning and we can do a little at the beginning. Okay, so now we are just going to create that function. So by the end of this, that's the last thing we want to create, and then we will call it a day. So I'm going to create a function and follow how I create the function. So I want to call it function underscore summary underscore stats. So I'm calling it summary statistics. And if any name, you can give any name. Then I bring my less than sign, with this. You can use equality as I said. Then I bring function. Okay. Now I want the argument to pick a data. And then I'm bringing something called variable index. Anything I'm putting here is completely your choice. You can give any different name to it. What I'm saying is that I want it to pick a particular data, any data. Okay, so this function I'm creating, when you use it for this data, you can use it for any other data and get all this the results I'm talking about. So first of all, the argument is it picks the data and the index. If you remember, if I type data underscore school, okay, this is the index. I'm talking about the index for the column. So if I put 1 here and I run, it gives me the first column. If I put 2 and I run, it gives me the second column data. So this index is just representing these 1s and 2s that I'll be using to extract. And then I open the curly bracket. Okay. So now look at how I'm going to create this function. So the function should be able to first of all determine the type of variable. If it's numerical, it should compute the mean, median, standard deviation, standard error. And then if it is categorical, then it should compute percentages. So now the first thing I'm going to do is I personally wanted it to return the names of the variables. So if the first index was name of school, I want it to also tell the type of variable. So I first of all create variable name, and I use this names in bracket data. So the names in bracket data, if you remember, I told you if you type names of your data, it will return all the names of the variables. So if you remember, if you run names in bracket school, someone is asking a question. Okay, Gertrude, someone was asking a question. Can you hear me?
Sorry, Clement, please go ahead. It was a mistake.
Okay, so if I type, sorry, the variable is data underscore school. So if I type data, so the first class will look a little bit challenging because you are now beginning to understand how it works. But you just have to get the video once again and go through little by little. So now when I'm done, I'll summarize what we've done. So when you are learning, it will make it easier. So basically, the small simple things we're doing. So if you remember, names of the data will return all the names of the variables. So that's exactly what I've used here. Just that now I'm not creating it purposely for this particular object called data underscore school. That is why I'm using a general name. You can use any name here, okay? And this function I'm using, you can actually use it for your research, and it's my own function, but it's fine, you can use it. So the first thing is I'm trying to save all the variables, the names of the variables. So if you remember, we use the square bracket for indexing. So if I put 5, it means that I want to know the name of the 5th column. So if I extract with 5 and I run, it gives me average height. Okay, so keep that in mind. So that is basically what I've done here. So I've not done anything strange. All right, and then the next thing is I want to determine the type of variable. So now we use something we call if and else statement. So the if, and keep in mind, mathematical programming is just how you will reason. So now I'm just saying that if the variable, and then what is the variable? Don't forget, it's going to be, let me just copy and paste this one to make our life easier. So here what I'm saying is that, so keep in mind, s.numeric is a way of asking. So if I should type s.numeric, okay, and I put, let's say school, sorry, is data underscore school, and I select the first variable, which is name of school. If I should run this, it says false. What this meant is I'm asking, is the variable I have put here numeric or not? If it is numeric, it will say yes. If it is not numeric, it will say false. Okay. So here, what this, so suppose I should put, let's say, the number of students. Now you realize that it says true. So the true means that it sees that as a numerical variable. But if I should change, is this a factor? So a factor is a way of referring to categorical variables. So if I say, is this a factor, and I should run this, it gave me false, meaning that the number of students is not a categorical variable. So you can use s.factor to determine whether a variable is a categorical variable or not. And you can also use s.numeric to determine whether a variable is numerical or not, as in numeric or quantitative. All right. So basically what I've just done here is to say that is the variable that I am considering. And don't forget, I'm considering the data and I'm indexing it by the index of the column. So here, if it is 1, if this one is 1, it means that it's going to be the first column. If it is 2, the second column, and so on. So this function I'm creating, keep in mind, it hasn't been created. So it's just trying to create something that you can easily use for your analysis and get your output, a lot of things at the same time. All right. So and then you open a curly bracket. So what it means is, so what we are doing, we are writing a condition. So the first thing is that we are asking if the variable is what? Numeric. If the numeric is true, as in if it is indeed numeric. And here you saw that I brought two equality. I told you that the normal equality is just like the less than with the negative sign. It's for assigning. If I want to really say equal, I have to use two equalities. Okay. So I'm saying that if the variable is numeric, now let me copy all these because of time. So if the variable is numeric, it should first of all compute the mean. So here you see, so I'm still using some of the inbuilt functions. Okay, so here I'm saying that it should compute the mean of that variable, and then it should compute the median. It should compute the standard deviation. So these are the inbuilt function for mean, just the normal mean, and then the median is just the normal definition of median. To calculate standard deviation, you use SD. So once you type SD in bracket, then you put the variable, it will calculate standard deviation. And then standard error is the standard deviation divided by square root of the sample size, right? So here I'm saying that this standard deviation that has been computed divided by square root of the length of the data. Always the length of the data will give you the sample size, keep in mind. Or you can use the dimension. I told you the dimension of the data returns the number of rows and then the number of columns. And always the first one is the number of rows and the second one is the number of columns. So you can also equally use dimension and extract the first variable or the first value, and that will also be the same as the length. All right, so I am done with computing the mean, the median, the variance, and then here you have to return. If you don't return, you cannot get the output. Now I want to return the mean, the median, the standard deviation, and the standard error. So here I can use something called list. Okay, so what this list, it helps me to return more than one thing. If I wanted to return only one thing, I would have just put the mean value here, and it will return just the mean value. Okay, but now I'm interested in returning more than one thing at a time. So what you do here is you use list. So list, then you open a bracket. Okay, then you copy the mean value. Oh, sorry. You copy the mean value, okay, equal to, then so the mean value is equal to this, or you can just consider the mean value, then comma. But I just want to bring equality here, because here you can put any name you want for it. So I could just say the mean value should be called mean, okay, and then it should return the median, okay. So here too, I can just call it median and bring equal to that, okay. You everything will unfold very soon, so don't worry. And the next one, I can bring it down, and standard deviation. So standard deviation, I'm just using the same name, so I can use the same name for that. And then it should also return standard error. So keep in mind, whatever you want it to return, you have to tell, okay. And this is because we are creating our own function and we are telling it to do what we want. So for the standard error, so at the moment, I've been able to now ask if the variable is what, numeric, it should compute all this and return all those things I've computed. All right. Else, if it is not numeric, so I can now copy this one. So here I could have still used this and say equals false. But here I just want you to also understand the s dot factor. So I'm saying that else if s dot factor, so else if the variable is a factor, okay, is a factor means if it's true, okay, because I told you if you use s dot factor of a variable, it tells true or false. If it's true, if the variable is indeed a factor, and it is false if the variable is numeric, okay. So here so else if it's a factor, then you open this. So keep in mind, this is what we call condition. So here you are putting a condition, and after every condition, you open it up and put whatever you want to compute if that condition holds. So here we are saying that if it's numeric, it should compute all these things for us. Else, if it's a factor, now we want it to compute percentages. So I'll just copy and paste this here and explain to you soon. So here, I'm saying that if it's a factor, it should first of all, so don't be confused with the paste and the round. So what I mean by round is, if I type round, let's say 2.35, you remember I said it should run to the nearest one decimal place. So if I type round and I put 1 here, okay, and I run, it will run the value to 1 decimal place, okay. If I let's say, let me put different values. So if I say I want to run this to let's say 3 decimal place, I just have to put 3 here, and it will run to the nearest 3 decimal place. So basically, these basic things are the ideas I'm still using in the function. So what I'm saying is that, first of all, and you remember the table was returning the number of observation under each category, if you remember. And if you remember, I divided by the dimension. So the dimension was trying to divide by the sample size. And then this index was just to say that, if you remember, the dimension returns the number of rows and the columns. And I'm just interested in the number of rows because the number of rows is technically the sample size, okay? And then I'm saying that, first of all, so now let me just consider tables, then school data, and let me choose sex. So now if you remember, this returns the number, and I said you can divide by the dimension of the data. So data, and this dimension returns two things. I want to extract the number of rows, okay, which is this. So if I should run this one, this gives me a fraction. But don't forget, what I want to do is that I want to get it in terms of 100, in terms of percentage. As it stands, is in terms of decimals. So I can just multiply the whole of this expression. I will bring a bracket trying to satisfy Boardmans. I'll just bring a bracket and put 100. So it means that this is going to multiply 100 to each of them. So now this tells me the males are what? 42 point, and the decimals are a lot. You are just interested in what? Let one decimal place. Then I'll put round around this one, open a bracket and close that bracket. Okay, and don't forget that this is what I've just done. So the whole of this gives me a particular value, which is like the 42 point something. And I'm saying that it should run the whole value in one decimal place. So I put one here. So if I should run this one, now you get the number of males to be 42.1%, females to be 52.6%. So it means with this one, you can use this to get easily what you want, like I said, in terms of the proportion. All right. Now I want to paste the percentage sign. So if you see this paste around here, it's nothing but trying to say that I want to bring paste and bring around paste around this one. And I'm saying that it should, and don't forget that with the paste, you bring whatever variable whatever number, then you can separate it with comma and put a percentage sign around it. So once I run this one, it will give me each value with a percentage attached to it. Okay, so we are just trying to make it handy so that at the end of the day, you get, you want to see, oh, 42.1%. So whatever you want to, you can just tell. So that's the essence of the paste. All right, so now with this two, so what I'm doing is that first of all, I'm computing the percentages. I am running it to the nearest one decimal place, and I want to put the percentage sign to it. Okay, and afterwards, yeah, so what I'm doing now is I want to create a data frame, okay, where the data frame will store the results that I had. Because of time, in our next lesson, we'll learn how to also create a data directly in R without necessarily for someone to do it in Excel. But keep in mind, always it's advisable to have your data saved in Excel. Okay, so now I want us to see what our function we just created is doing. So this is like a magic function. So now you highlight, so you see this function is from here to this side. Oh, sorry, it's from here. Let me bring this up. So the function is from here to there. So you see one function we've created it such that it should determine the type of variable. If the variable is numerical, it should compute the mean, median, standard deviation, and standard error. You can add more complexity to this. And if it is not categorical, that is, if it is categorical, then it should compute the percentages and return it as a data frame where we will know the percentages, okay? At the same time, we will know the names of the categories, so that if it's males, I want to know the males and their corresponding percentage. And don't forget, I have to bring return here. So I want to return this output. If you don't bring return, you will not get the results out. Okay. So now let's run the whole function. Okay. So I've run this function. So to run the whole function, you realize that I highlighted everything. Okay. So now let's see whether the function is working. So I'll copy this summary stars. And then, so this is the last thing we are doing. And now the name of the data, you remember the argument was data and the index, variable index. So let me just copy this one, okay, and paste it here. All right. So first of all, the name of the data was data underscore school. All right. And then the variable index. So what I just did, you realize that we have created our own function. Now it's picking the data and the variable index. Suppose you want to know the summary for the first variable, you put 1 here. Okay, if it's for the second variable, you put 2. If it's for the third variable, you put 3. So you can actually use the names. You can actually use names in brackets school to get the variables for you to know which of them you are interested in. So suppose you are interested in knowing the region. So the region is the 8th variable. The region of the school is the 8th variable. I just have to put 8 here. And now let's see what comes out. So I highlight this one and then I run. Have you seen that it has returned the variable is it has returned the school, the region of the school, the categories and their corresponding percentages. I told it to do it that way for me. I can choose for it to return it as a list, which is not like a data frame. Now, suppose I want to know about the weight. So the weight was which, so let me run this one. So suppose I'm interested in knowing about the weight. The weight is the C's variable. So I'll put 6 here and let's see what happens. 6. So if I run this one, as you can see, let me calm down. You can see it has returned the mean, the median, the standard deviation, the standard error. You can actually add more complexity for this function to, first of all, pick each variable, tell the summary statistics, and even plot a graph for you. Okay, so that's one of the things about creating a function in using a programming language. So you can create a function and add as many complexity as you want. Technically, originally, I even told it to calculate skewness and ketosis, just that I didn't add it to this because of time. So at the end of the day, so this is basically trying to say that with R, you can tell it to do anything you want, and things that you do in other programming language, other software, statistical softwares like SPSS, Stata, that you struggle, you can easily get your outputs, okay, without any how do you call it, without any much effort. So basically, to summarize what we've done, so let me just summarize what we've done and we call it a day. So first of all, we've learned how to first of all set a working directory. And we said that if you don't set a working directory, importing the data can become challenging a little bit. So first of all, setting a working directory means that you should always create a folder on, let's say, your desktop where your data should be there. And this script that we just used, don't forget, you can save it. Just go to File, Save As, and the save as will open them. Then go and select, you go to desktop, you select the folder, and you just click what, save. Okay. Yes, I'm replacing it because I already had it saved. So now I have saved my file. So it means in future I can import it back. I can call this function back. I just have to go to File, Open File, and open the script. Okay, open the script which I've opened. So basically, that's the beauty about having a folder, or in this case, setting a working directory. So the working directory too, when you go to your folder, I told you, you just go and copy that link. And when you paste the link, you see that the slanting, this slanting line that points to the right now will be pointing to the left in the original in the original link. Okay, so you have to make sure, so it will be pointing to the left like that. You have to make sure you make it point to the right. Okay, and then don't forget to bring your quotation mark, your quotation sign, and paste and change these ones to point to the right. Once you do that, you've set your working directory, you run it. To run this, you just highlight it and then you run. Or you can let it blink here and you run. It also works, okay? And then the next thing is how to import the data. So if the data you saved in CSV, you saved it as school underscore data. If you forget to bring the underscore and you make it this way, you get an error, okay? So you bring the underscore and then you don't forget to bring .csv because the data is now saved as a CSV. So, and you just run and it will read it directly from that your folder, okay, directly into R. So that's how easy you can import the data into R, okay? And then the next thing is that some variables, we assign variables like sex of school as 1, 2, 3. But we need to tell R that 1 stands for male school, 2 stands for female school, and 3 stands for what? Miss school. Okay. And then regions too, we needed to tell R that 1 stands for Ashanti, next the 2 stand for Central, and 3 stand for Greater Accra. So this is how easy you can actually assign what? Assign codes, names to some of your categories. And after that, we have learned that you can extract the headings of your variables by just typing names, and you put the data inside the argument and you run. That will give you all the names of your variables, okay? And you can also indentation too. We do indentation using the square brackets. While the round bracket is used for, or the round bracket is used for as input, where you put the input in there. The square bracket is for is for extracting. Okay, so first of all, if I want to extract, let's say the first 10 rows, I just put 1 to 10. See how I did it? One, so this column sign means 1 to 10. So it means even in R, if I should just copy this one and paste here and just run R to 10 without, you realize I didn't bring any C. If I run this 1 to 10, it will print out a vector 1 to 10. So it will print out something that looks like C with 1, 2, 3, 4, 5, 6, 7, say 7, 8, 9, 6, 7, 8, 9, 10. Yeah, so it's with the commas. Okay, sorry for that. With the commas. All right, so today we couldn't do much because it's our first time. We are trying to get familiar around this one. So when you run this one, it gives you the same results as 1 to 10. Fine. So this is how to do indentation, and indentation is very necessary, and we learn that as time goes by. So if I want to know the first column, I just have to put one in the second part of this comma. So don't forget, we have two parts. So you bring the square bracket, you bring a comma. This first part is to extract any rows. So suppose I want to extract the first 10 rows, okay, but extract the next, the first 3 columns. I just put 1 to 3 here. So when I run this one, it will do exactly what I want. So I wanted it to extract the first 10, but the first 10 rows. So it does up to 10. And then the first 3 columns, 1, 2, 3. Okay, so that's the beauty about the indent. So you can use this one to extract anything you want. Okay, and now we've learned how to create basic functions. Okay, and we said that to create a function, you just always have to start with an object name. And what is an object name? An object name is trying to give a name to any function. So I can put an object name, so you can use any name for it. So here I was trying to create a function and I'm calling it summary stat. And I said you can use either equality or this sign less than with the dash. And then you write the function, you put your input, and within the input you can add any complexity you want within the function. So I wanted, first of all, to ask the type of variable. If it's numeric, it should compute the mean, median, standard deviation, and standard error. If it is categorical, it should compute the percentages and then return them as such. So this is just a way of creating functions. Okay, just that I did something a bit complicated. So this is just the first meeting. So the first meeting is just for us to get familiar with R. Then in our next meeting, we would actually, because we couldn't finish today's task because it looks like it was a beginning. So, and I thought the content could be done in 1 hour, but I forgot technically we are dealing with people who most people don't know R in the first place. So we could only do up to this point. So next week we will take it from here and then continue on the same task that we wanted to do, because there are many things. We need to first of all produce some descriptive plot, how to do some bar charts, histograms, and then how to do other advanced data analysis. And then we'll learn how to use functions and how to do other simulations and so on. So I'll end here, and then if you have any question, don't forget to ask on Piazza. And then we are going to create a YouTube link, a YouTube video. So this is recorded already. So you have it in YouTube and a link will be sent. So you'll be able to go over what we did. Okay. And then I'll make sure I let you have the course. And then, but for now, just go and practice and then watch the YouTube, and don't forget to subscribe. There are a lot of things we are going to do. And since this is just the beginning, we couldn't do much, but I think the 1 hour was a little bit small. So maybe this is just like a pre-study. So we will see if we would just do 1 hour, 30 minutes. and then go further. So this is just the beginning. So don't feel intimidated and don't be scared about R. It's really friendly and you can do a lot of things easily. Thank you very much and see you next week. Thank you. All right. So I'll leave you now and take care. Bye.